Okay. Ow. Now I'm back from the gym. Now I'm back. My camera is finished uploading to my computer. So I can continue with this. Lovely. This lovely. Let's see. Okay. Section 4. I guess I'll read this. I don't remember if I read it before. Section 4. First AMIF amplifier. The operation of the first IF amplifier is the same as the second IF amplifier, and with one important difference. The gain of the first IF amplifier decreases after the AGC threshold is passed to keep the audio output constant at the detector and prevent overload of the second IF amplifier. This is accomplished by making the voltage on the base of transistor Q8 lower as the signal strength increases. Since the voltage from base to emitter is fairly constant, the drop-in voltage at the base produces a similar drop-in voltage at the emitter of Q8. This drop lowers the voltage across R37 and thus reduces the DC current through R37. Since all of the DC current from the emitter of Q8 must go through R37, the DC current in Q8 is therefore lowered. When the DC current in a transistor is lowered, its effective emitter resistance increases. The AC gain of transistor 8 is Q8 is equal to the AC collector load of Q8 divided by its effective emitter resistance. Raising the value of the effective emitter resistance thus lowers the AC gain of Q8. Assembly instructions. R34 1 mega ohm resistor, brown, black, green, gold. That's that one we were fucking with earlier. And I was like, you know what? Fuck all that shit because it's dumb. Yeah. Okay, and this one is R34 1 mega ohm. That's this one right here. Oh, I should probably turn this on. And bend this other side. It's alright. And I'm gonna put it in this way, R34. Down in there. And we're already ready to start soldering. Already ready. Already ready. Okay. There we go. Where'd it go? There it is. This one connects here. And now I can breathe. Okay. Good. Okay. Checking continuity. From here to here. Yep. And from here to here. and there, and here. And we good. And I can chop off the leads. Okay. Check it off on the list. Test point number 6. Caution, test point must not touch can of IF coil. Didn't tell me to watch out for that on the fucking previous one, test point 4. But I was smart enough to do so anyway. And say a big fuck you. I'm just being silly. Oh, that's a differently shaped one. I'm gonna put these off to the side in a little pouch. Okay. There's a test point. Oh, knocking shit off the table. It's only the base. I don't care about that base. What else do I need? I need a transistor. I'm gonna need this. This. I'm also gonna put these in a suitable location so I don't lose them. See how much fucking solder I have left? I think that's supposed to last me the entire kit. I don't know, but I think so. I mean, I didn't take a look through the FM parts yet, but clearly not enough. Alright. Organization is key. Okay. Anything else? Disc cap, resistor, transistor, test point. That's all this at this point. But we're pretty close to the end of the parts here, so that's pretty exciting. It's pretty exciting. Don't know about those. Okay. Put that up to the side. Test point. There it is. Don't let it touch. I'll pop it off to the side like this at an angle, and that'll do well. Okay, here it is. Okay. Pointed at an angle and not touching anything except for R34, but it's permanently touching R34, so that's okay. At this point, Q8 transistor. That is this one in the middle. And that is indeed 2N3904. 2N3904. Bend these ones out. And forward. And the base back. And poke it in. I say. And get it to be about 1/4 of an inch up without doing that. 1/4 of an inch approximately. Good enough. Check. Yep. Oh yeah. I forgot I was going to set up a movie. It won't take long. I'll continuity test this check first. This one to this one. It would help if I did that, this. Not that. I'm surprised it attaches to that one. Those two don't connect, that's good. I guess it connects through this. I don't know. Whatever, I guess. And that one connects with those, which is good. And check it off. 2 seconds. Okay. Alright. I love this movie. Okay. I should probably move that out of my way. There we go. What is next? C35 0.02 microfarad discap 203. Another one of those. That one right there. And this 203 goes I love that these are all cocked to the side. They're all, at least they're all cocked the same way. Okay, this number 203 is C35, which is that one right there. And I'm gonna have the text pointing to the right because I decided to do it that way. Oh, I didn't cut off the leads from that previous one. Okay. There we go. Like that. And like that. Okay. And continuity check. Between this one and any of these, anything, that one and this, and that, that's good. Cut off these leads. That'll be better. Okay. R37 1000 ohm resistor or 1K ohm resistor. That is brown, black, red, gold. That's this guy up here. That's R37, which goes right next to that one right there. Brown, black, red, gold, R37. Okay. That looks good. Okay. Continuity. Looks good to me. Okay. Static measurements. Q8 base bias. Connect your volt-ohm meter to the circuit as shown in figure 23. Set your volt-ohm meter to read 2 volts DC and turn the power on. The voltage at test point 5 should be approximately 1.5 volts. If your circuit fails this test, check Q8 and R37. Turn the power off. Q8 current. Connect the positive lead of your voltometer to the emitter of Q8 and connect the negative lead to the ground point, test point 15. Turn the power on. The voltage should be approximately 0.8 volts. Since the current in Q8 is equal to the current in R37, I Q2 equals 0.8 divided by R37, or approximately 0.8 milliamps. Turn the power off. So, I'm gonna take a look at the picture. That is apparently on a previous page. Seriously, I have to flip back. I mean, you know, good on them for not reprinting the same thing over and over again, but it's a little bit, it's only a slight pain having to flip to a previous page. Figure 23 on page 24. It'd be nice if it said what page. Ground on 15, test point 5. Ground on 15, we're doing DC volts. Ground on 15, test point 5. .4. Test point 5 should be approximately 1.5 volts, and it is 1.421. So that's good. Connect the positive lead to Q8, the emitter of Q8. That's this one. And the negative to the ground point. Ooh, very close to 0.8. 0.98, 0.798, so yeah, that's like exactly what it's supposed to be, pretty much. 798, not too bad, not too bad. Good. Okay. If you do not have an RF generator and oscilloscope, skip to section 5. Yay! Oh, it's right there. AM mixer, AM oscillator, and AM antenna. In a super heterodyne type receiver, the radio wave at the antenna is amplified and then mixed with the local oscillator to produce the intermediate frequency, IF. Transistor Q7 and Transistor Q7 not only amplifies the RF signal, but it also simultaneously oscillates at a frequency 455 kilohertz above the desired radio station frequency. Positive feedback from the collector to the emitter of Q7 is provided by coil L5 and capacitor C31. During the heterodyning process, the following four frequencies are present at the oscillator, at the collector of Q7. 1. The local oscillator frequency, OF. 2. The RF carrier or radio station frequency. 3. The sum of these two frequencies, OF plus RF. 4. The difference of these two frequencies, OF minus RF. Ooh, I'm at the middle of the book. The difference frequency is used as the intermediate frequency in AM radios. The collector of Q7 also contains an IF transformer, T6, tuned only to the difference frequency. This transformer rejects all frequencies except those near 455 kHz. T6 also couples the 455 kHz signal to the base of Q8 to be processed by the IF amplifiers. The antenna and the oscillator coils are the only two resonant circuits that change when the radio is tuned for different stations. Since a radio station may exist 455 kHz above the oscillator frequency, it is important that the antenna rejects this station and selects only the station 455 kHz below the oscillator frequency. The frequency of the undesired station, 455 kHz above the oscillator, is called the image frequency. If the selectivity of the antenna, Q factor, is high, the image will be reduced sufficiently. The oscillator circuit must also change when the radio is tuned in order to remain 455 kHz above the tuning of the desired radio station. The degree of accuracy in keeping the oscillator frequency exactly 455 kHz above the tuning of the antenna is called tracking accuracy. Well, let's do this one up here first. C28. 0.1 microfarad disc cap, 104. That'll be this one up here. Hmm. 104. This is C28. C28 is in this general location, right there. Facing the text down just because I decide that. And we do this. This movie's so sad and so sad. I'm like fighting back the tears over here. Alright, another continuity check here. That's good. Connects all kinds of things. Okay. Okay. Next. Well, check that off first, I suppose. L4 AM antenna with holders. You know, I think I'll just do everything else first. Yeah, I'm gonna do everything else first. R31, 56,000 ohm resistor, green, blue, orange, gold is one of these guys. 56. That's this one. Green, blue, orange, gold. Hey, those are my 3 favorite colors. Not gold. Gold is a metal. It's also a color, but it's a very, very particular kind of color. It's more of a property of light. Color is more of a color is just referring to the frequency of which something is. Whatever its frequency is. Whereas like something like gold is more referring to a particular shade as well as a number of certain properties. The shininess, the reflectivity, and the specularity. R31, green, blue, orange, gold. The 56,000 ohm resistor. This one right here goes R31 right here. Like that. Okay. Continuity. This to this, or this, or this, or this, or this, but not that. No, maybe that, I guess. It's not connected. I don't know how it's connecting. Probably through this. This is one of those, whatever those things are called. Coils. Okay. Clip. Okay. I'm going to check that off. C30 150 picofarad disc capacitor. Really? It's a itty bitty. That is a 151. Little bitty. That's what this one is. Okay. This is C30. And C30 is up here. I'm gonna put it like this. Okay. Okay. And this. Okay. Damn. Where did that go? Got it. Okay. I'm gonna check it off early, but I'm gonna still do a continuity check. From here to here. From here to here. Okay. And gee, this stuff just keeps unspooling itself. Maybe I'll keep it in here. That'd probably be beneficial. Okay. I can clip those leads. Okay. Next. Okay. AM oscillator coil red dots. That is this little guy. Now 5. AM oscillator coil. Yeah. AM oscillator coil red dot. That's this one. And okay. Alright, continuity check. Good. Okay. That's the last of the coils. I have to fucking put a jumper in here though. That's a nice long one. I love these tweezers. Absolutely. Alright. Hey, that's the next thing too. This jumper. I suppose the point of these jumpers is so that you can test the circuit. You can test different things without other things being connected initially. I'm just guessing. Because I don't know why they would have it like that if that wasn't the case. Okay. Okay. Continuity. Good. Okay. And next. Test point 7. That. I'm also gonna need disc cap. Resistor, disc cap. Alright, good enough. Okay. Test point number 7. Right there. Robert. Alright. Okay, just 1.7 C31.01 microfarad diskette, 0.01. Okay, so this is the 103, which is indeed a 0.01 microfarad diskette. C31 is this right here. If I can get it in, teehee. More continuity checks. It would help if I'm in continuity mode. It would help if I was in continuity mode. There. Okay. What next? Next thing is this Q729 or 2N3904, 2N3904. goes into this, maybe, unless it doesn't feel like it. Nah, I don't feel like it. No, that's entirely wrong. Entirely the wrong way. Okay, that's better. Now I got it faced the right way. Okay. Okay. Continuity check. Here to here. Here to here. And here. And there, there. There, there, there. There, 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 there. Okay. That looks awesome. Alright, that's Q7, R32, 12K. Ohm resistor, orange, orange, red, gold. R33. Orange, orange, red, gold. Oh, well, I'm skipping. Okay, this is I'm sorry. This is R33. 3.3K ohm resistor, orange, orange, red, gold. And this one, R33, goes here. Continuity check. kind of poke everything. Stella. Okay, let's do the one before that. R32 is the 12K. 32 isn't even on here. Nope. Brown, red, orange, gold. Okay, R32, 12,000 ohm resistor, brown, red, orange, gold. Brown, red, orange, gold. This one. Get off of there. Okay. Okay. Brown, red, orange, gold. 32. That's this one right here. Hey now, what are you doing flattened down? I didn't tell you to flatten. Okay. 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 Yeah, well. Okay. Lovely. Okay. Let me check that off. Where's my pencil? There it is. I found it. Alright. That is all those. And that is exciting to me, which means we are so close. We are so close. And then C29.02 microfarad disc cap, 203. 203. Eh. .203. C29 is down here. Okay. Oof. Continuity. Pardon me. This one to this one. This one to any of these. Okay. I think I might want to watch Harry Potter after this. 'Cause I'm totally a dork like that. Alright. That is everything. That's all the capacitors from the AM kit. That is all the resistors from the AM kit. The diodes, the transistors, everything. Except for what is on here. And what is on here is what is next. We've got L4 AM antenna with holders. That is this weird thing looking right here. Put that off to the side. I have one here. That looks yellow. And I've got 3 here. I got a green, a blue, and a red. These ones are twisted together. Are they supposed to be? We'll find out, actually. It tells me. But this weird rod thing. I'm gonna be so excited to be listening to AM radio. It's gonna be awesome. Alright. We'll do this. I guess. We'll do that. And that thing's pretty heavy. When I saw this kit, I was like, what the... Does it come with a cigarette? Like, what the hell is this thing? I was confused. It's like a... It's almost like a cigarette. Okay. Okay. L4 AM antenna with holders, figures L and M. Determine if you have a 3-wire or 4-wire coil. I have 4. Okay. Resistance measurements will be used to check the configuration of the coil. Slide one holder off the ferrite core of the antenna assembly. That's what it is, ferrite. Of the antenna assembly. Then slide the coil off the ferrite core. Okay, let me read that again. Resistance measurements will be used to check the configuration of the coil. Slide one holder off the ferrite coil of the antenna assembly. Then slide the coil off the ferrite core. Measure the resistance of the coil. Your reading should match the approximate values as shown. Note: if the end of a wire from the antenna should break off, strip the insulation off the end with a hot soldering iron. Lay the wire down on a hard surface and stroke the wire with your iron. Stroke it! The insulation should come off very easily. Caution, the soldering iron will burn the hard surface that you are working on. So, okay, so I've got 4 wires. White, black, red, green. White, black, red. So let's take a look at this. That's supposed to be black? I thought it's blue. I guess it's black. I got this, which I guess is supposed to be white, even though it looks yellow. White, blue, green, and red. Between whites and black, let me take a look at this. Before installing the antenna coil, determine if you have a 3-wire or 4-wire or 3-wire coil or a 4-wire coil. Tongue twister: assemble it to the PC board as shown. Mount the antenna assembly to the PC board. Okay. There's this, which is apparently the white, which is C. There's black and red. Twisted together. Or, oh, thank you for giving me the 4-wire one. 4-wire type antenna. Solder the 4 colored wires to the PC board. Wire A, green, to the hole marked red. Okay. Wire B, red and black twisted together to the hole marked black. And wire C, white, to the hole marked white. Here's red. There's black. There's white. Okay. These are twisted together, kind of. I will do a little bit more of that. Twisted together they are. Make it look pretty. Pretty. Okay. Now it's 3-wire. Now the question is, this tells me to measure between the white and the black. Hell, I can't even tell. I'll do this. Between this one and this one. Measuring the resistance. Change it to resistance. And touch it to the black one. I'm touching it, I'm probably messing with it. Okay. There. Nothing. Okay, so this one. Nothing. Huh. Nothing. I'm getting 0 between this white one and either of these. I'm getting nothing. How about what if I do across both of them, if I can manage that? Eee! Something is hot here. That is super hot. Maybe it would be better if I did not leave this on. I'm surprised it was on because it's usually not on, but damn, that thing got hot. Well, it's supposed to be the white one. Huh? Oh, I'm getting a reading now. 10.4 ohms. Between the white and the black, we are supposed to get is that connecting both? Yes, no. Yes, no. Yes, no. No, no, yet no. That's pretty much what it's doing right now. We try this again. Okay. Stay down. Stay down. Stay down. Stay down. Stay down. God damn it. Stay down. Okay, good. Okay. Son of a bitch. Get it. Just stay. Okay. Stop it. Stop it. Stop it. Stop it. Son of a bitch. Okay. Okay. Between the black and the white, nothing. Between the black and the red and the white. Ten 10.5, 10.4, 10.5, 10.3, 10.2, 10.1, 10.0, 10.2. That's across both of them. So I'll consider that good. And then from the red one to the green one, I should be getting the same fucking thing. Oh, thank you. Thank you. Thank you. Okay. $30. This would be so much easier if I had fucking alligator clips. I don't want to touch it myself. Between 1 and 1.5 ohms. If I could. Dude, this is a time when I'm like, you know what? It'd be really nice to have 4 arms. That'd be awesome. One 1.7, 1.6, 1.8, 1.5, 1.4, 1.5. Close enough, whatever. Same goddamn thing as what a 3-wire assembly is. Okay. Now, this question is here. How does it stay in place? Put the tab of the first holder into the right hole and twist the tab 90 degrees. Put the tab of the second holder into the left hole and twist the tab 90 degrees. Slide the ferrite core through the holders. Slide the antenna coil through the ferrite core. Or slide the ferrite core through the antenna coil, technically speaking. If the end of a wire from the antenna should break off, strip the insulation, blah blah blah. Punch out one antenna shim from the front flap of the box. And this is why you do not throw out the box. It's right here. I was so tempted to pop these off earlier too, but it tells you, save the box, you need this. And that's from right here. That's what that is. So, hiccup. Punch out one antenna shim from the front flap of the box. Insert the cardboard antenna shim between the ferrite core and the antenna coil. This will temporarily hold the coil in place. Okay. It actually has a picture like either like this or like this. Shim. That thing heated up. Okay. 4-wire type antenna. Solder the 4 colored wires into the PC board. Wire A, green, to the hole marked red. If I was doing a 3, it'd be in a different one. So this green one goes here in the red hole. This twist of black and red into the black hole. And the white into the white. This movie is so sad. Okay, solder 4 colored wires to the PC board. Wire A, green, to the hole marked red. Wire B, red and black, twisted together to the hole marked black. B, okay. And wire C, white, to the hole marked white. Whipped, WHT. I don't know what's supposed to keep this in place other than this. So I'm just gonna leave that there for now. It doesn't show like anything in particular on where the wires should go. I'll take a look at the front of the box, see what it shows me. These wires, they're just kind of all over the place. It's good to know. Okay, so. Oh, hush you. We'll do... That's alright. You know what? Actually, I kind of want to watch an anime now. Good job. Okay. here. I'm gonna just bend it off to the side. Should be good. Good enough, at least. Yeah, sure. Here's another situation where a tiny bit of solder would be nice, because don't have to worry about it fucking up. Yeah, we'll do this. And then we'll move on to the next thing. Waiting for it to heat up. Okay. Good. Okay. That's those 3 wires. We'll just kind of coil them up a little bit, I suppose. Okay. I don't know if this is supposed to be free floating. But maybe it is. I think that's a magnet, or at least a polarized thing to keep something away from something else. I don't know. Let me see here. Check these off. The A, the B, and the C. And that is the AM antenna with holders. C1 tuning gang capacitor. That's this guy. And that has a particular particular way about it. Says a knob. Oh, it gets fastened to the capacitor. Alright, well, I'm gonna put the sticker on this. Or will I? Fuck it, I'll leave it till later. Okay. Okay. What are these other 2 screws for? Did I miss screwing something in? That doesn't need screws. Alright, it's important to know which of the 2 types of tuning gain capacitor you have received with your kit, look at the gain capacitor that you have. It's either one of these or one of these. One of them looks like the one that I have, this kind. And one of them looks like this kind. Where is it? Doesn't even call them, doesn't even say different things. Okay, so, FM antenna trimmer. What does it say? TTWM. Doesn't say. Well, one of these says there's C1 on this side here, C2 over here, C3 and C4. So that is like the picture. It's got these guys are at angles, whatever, and that one's more of like 90-degree kind of deal. So there's or is it even fucking, well, okay, maybe not, I don't know. Fuck, whatever. This shows me C3 and C4 has the locator pin side. That's that one. And it shows the top like this, like that, which I max. But this is C1 and C2, which is like what this says with the locator lead on that side, but it doesn't look like the top. This is so confusing because it's lying. So I don't know. Fuck, man. Either way, I'm just gonna disregard the fucking top picture because either way the locator lead goes in the bottom slot. Okay. Fucking confusing, but whatever. This goes on the bottom side of the board. So you mount the tuning gain capacitor to the foil side of the PC board with the AM and FM sides in the correct direction. Yeah, okay. These movies are sad. Alright. Okay. Fuck it, man. Either way. Locating pin. Goes this way. That one goes to that. That one goes up. Saddest part of the movie ever. Okay, so that's what gets screwed in place. Okay. Yeah, step it. Okay. Alright. Fasten the gang with these 2 screws in the front here. Uh-oh. Oh, 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 oh. I see them. They're right there. Eesh. Okay, here it is. The littlest bittiest one. I'm trying. There we go. S1. Okay. That's good. Fastened in place. Solder the leads, cut off the excess. Oh, I see. Cut off the excess leads coming through the front side. Damn, that thing really did burn me. It was fucking hot. It was cooking. This thing? It was cooking. I don't know if it's supposed to be cooking, but I don't think it's supposed to be cooking. Apparently I won't be using this too terribly often. Probably. No. Whatever. Okay. to put this in better view. Saddest part of the movie. Well, the other part was pretty sad too. Okay. Cut off the excess leads. I'd kind of like to see if this works first. Um. Trying to get those wires out of the way a little bit. Whatever, I suppose. I'm gonna check if this works first. Static measurements. Oh, dicks. I gotta short something. TP6. TP6. Where are you? TP6. Oh, hanging out over here. Short TP6 to the collector of Q7. As shown. We'll try. Maybe we won't try with that one. Maybe we'll try with this one. Being difficult. Is this even gonna do anything? Do me any good? Clip lead. I don't have a clip lead. Clearly this kit is for people who are teaching people how to do this and not just people on their own, because I don't have any of these things. Why you be so difficult? I'm surprised the movie didn't start over again. You know how DVD menus work. Okay. You can do it. I believe in you. Why are you such a dick? Go in the hall. Go in the hall. Do it. Seriously. Most difficult fucking thing ever, apparently. Just not even. Close enough. Mangled bullshit, but close enough. Just fucking touch and then don't move. It's okay. Okay. That should be okay. As long as it's not touching the can. It's touching the can. Damn you, damn you. Twist. Thing. Fuck it, close enough. Okay, shorted. The short prevents Q7 from oscillating. Set the voltometer to read 2 volts DC. And turn the power on. The DC voltage at test point 7 should be about 1.6 volts. If the voltage on your circuit differs by more than 0.5 volts, leave the power on and check the battery voltage. If the battery voltage is greater than 8.5 volts, check components R31, R32, R33, and Q7. If the battery voltage is greater than 8.5, but it's a 9 volt battery. Okay. Turn the power on. Test point 7, grounding on test point 15. And then finding test point 7, which is down here. I'm going to do that, and then turn it on, and manually turn it on, because however this thing clicks in place. Bent the shit out of that. Okay, trying it again. Test point 7. Should measure 1.6, about 1.6. If it differs by more than 0.5. That's like 1.6. It's 1.4, so it's it's almost 1.5. 1.49 is 1. I'm gonna just talk about it in thousands, machine shop thousands, because that's how I know. So it's about 1 to 100 thou. So that's like just fine. Whatever. I don't need that at the moment. Yeah, I guess that thing takes a while to heat up. Turn the power off. Power's off. If you do not have an oscilloscope, skip to the AM final alignments. Well, I guess I'm gonna do it. I'm gonna take the leap and clip the leads. Shut that off. Clippy device. Oh wow, that just dripped down. Okay. And once I get this, I'm gonna put this on in this position. Trying to get it pretty much straight up and down. Relatively decent, I suppose. Oh well, okay. Fasten the knob to the shaft of the capacitor with a screw. The screw, the only one left. Rotate the knob fully clockwise. Okay. Rotate the knob fully clockwise. Peel off the protective backing on the label. Line up the long white lines on the label with the arrows on the PC board. And it shows AM hertz up at the top and FM hertz on the bottom. Let's see how well I can do this. Good enough. So, then if I switch it, these would be the AM frequencies. Approximately. And these would be the FM frequencies that it's pointing to. Is it still on? No, I turned it off. Good. Okay. Let me make sure everything's checked off over here so that I know that I did everything. Tuning gang capacitor, that's a big check. 2 screws, the knob, the screw, and the label. Those are all good. And all that stuff is good as well. We're just gonna... yeah. Okay. Maybe it'll actually be heavy enough to make this thing useful. Yeah, I got it. Here it is. Goes like this. Hee hee hee. Okay, so here's a lead attached to that. Finalizations. I already did that stuff. AM final alignments. Oh. So that's what that is, I guess. Meh. Whatever. Where'd my antenna shim go? There it is. Put that there. Okay, AM final alignments. There are two different AM alignment procedures. The first alignment procedure is for those who do not have test equipment, and the second is for those that do have test equipment. Included in your kit is a special device called a magic wand, which is used for aligning resonant circuits. It usually has a piece of brass on one end and a piece of iron on the other. When the brass end of the magic wand is placed near the AM antenna, the antenna coil will react as if inductance has been removed. Likewise, when the iron end of the magic wand is placed near the AM antenna, the antenna coil will react as if inductance has been added. Therefore, when either brass or iron is placed near the antenna coil, it will change the inductance of the antenna coil. This change in the inductance will cause the resonant frequency of the circuit to change, thus changing the frequency at which the antenna was selective. When aligning the antenna, and oscillator circuits, coils L4 and L5 are adjusted at the lower end of the band. Where'd the other lead go here? Put these off to the side, because I don't need them. Therefore, when aligning the antenna and oscillator circuits, coils L4 and L5 are adjusted at the lower end of the band, while the oscillator and antenna trimmer capacitors are adjusted at the higher end of the band. This is done so that the antenna and the oscillator will track correctly. Magic wand assembly. Place the piece of brass inside the end of the shrinking tube with 1/4 of an inch outside. Heat the brass up with your soldering iron until the tubing shrinks around the brass. Assemble the iron piece to the other end in the same manner. So I still need this on, I guess. One-fourth of an inch is about half of this. Rolling, rolling, rolling. So, that didn't work. Gotta turn that off. Okay, same thing with the iron end. You know what I need to watch? Firefly. I never finished it. And it's starting to shrink. Okay, we'll let that cool for a little bit. This is apparently a magic wand. Okay. AM alignment without test equipment. It is best to use an earphone for this procedure. Make sure that the switch is in the AM position. It's also off. This is probably what the earphone is for. Please don't bleed. Please don't hurt my ears. I'm gonna plug this in. If it'll let me. Little bit of difficulty. I might need that pretty soon, actually. Might. Keyword. Okay. We're gonna put this in. Okay, I need a screwdriver. We're now doing alignment. And it says, it's best to use an earphone for this procedure. Make sure that the switch is in the AM position. With an alignment tool or screwdriver, turn coils L5, T6, T7, and T8 fully counterclockwise until they stop. Do not force the coils any further. Reason being, if you try and force them further, they might go further, but you're probably going to wreck your soldering. Turning this fully counterclockwise. Clockwise. Dicks. Counterclockwise. Well, I don't know exactly when they stop, but okay. Turn each coil in about 1 1/4 to 1 1/2 turns. One and a half. Set the AM antenna coil about 1/8 of an inch from the end of its ferrite core. Rod. Now, the entire assembly or the actual coil bit? It's kind of an important question. We'll find out, I guess. Maybe. I don't know. Turn the power on and adjust the volume to a comfortable level. Turn the dial until a weak station is heard. If no stations are present, slide the antenna back and forth on its ferrite core and retune the dial if necessary. Okay. We're gonna do this slightly differently so that it can be seen. I'm gonna turn it on. It's loud. Okie dokie. And turn this. Can it be heard? Damn, this thing is fucking... jammed in there. Woo! Hold on a sec. I'm not hearing anything from the speaker. I am hearing stuff from the earphone jack. But I am not getting anything from the speaker. I should be getting something from the speaker. So I'm kind of disappointed at the moment. Ooh, I don't know what else I should do. That might be a good idea. Oh. Okay. Okay. I don't know if you can hear this. But there is the tiniest bit of fucking noise right there. Just with the speaker. So yeah, definitely I'm gonna have to do this with the earphone jack. So you won't be able to hear this part. But I will tell you how it goes. Yeah, that's gonna have to be how it works. Okay, so I'm gonna turn this on. And is in the AM position. Now tune this. Turn the dial until a weak station is heard. Static. Loud static. Louder static. Fucking loud static. Progressively louder static. Fuck, man. You hear that? We'll do this. This sounds better. Turn the power on. Let me just wrap this around that. There you go. You get to experience the lovely static. The lovely static. Okay. Turn the power on and adjust the volume to a comfortable level. Ha ha ha. Turn the dial till a weak station is heard. If no stations are present, slide the antenna back and forth on its ferrite core and retune the dial if necessary. Hold on, let me... Jesus, that's loud. hearing any stations. I'm gonna turn it off and I'm gonna look. I'm gonna see. I'm gonna see. AM radio. AM radio, 530, 570, 590, 600, 680, 920, 940, 950, 970, 1230, 1230. There's two of them at 1230. Okay. There's also two at 1240. 1340, 1320, 1400, 1430, 1450, 1490. So, there are a bunch of different radio stations that I should be getting. There's one news talk / full service. Well, news talk and full service. Those are both out of Escanaba. 600. That's way over here. I'm gonna tune it to 600 approximately. And I should be able to hear a station. That's supposed to be a station. Let's see if Lovely noises. Oh, fucking... I still got this goddamn thing shorted. Fuck. That might have been fucking with this. Let's try this again. Without that goddamn thing shorted. Shit. Oh, yes. Oh. Fucking AM radio has never sounded so sexy. Oh. Alright. Alright, let's try this. Let's try another one. Let's see if we can get something else. Okay. Adjust T6 till the station is at its loudest. Oh, AM radio. Never been this sexy. Alright. Ah, I just blinded myself with sound. That's special. Okay, let's do some adjustments. I'm putting the earphone in so I can actually do this. T6 is this one right here. Yeah. Reduce the volume if necessary. Adjust T7 until the station is at its loudest, and reduce the volume if ow, damn it, necessary. T7. Dude. This is the coolest shit right now. Like, I've never done this before, and it fucking works. Damn, man. Dude, so awesome. AM radio, seriously. Fuck, man. Awesome. I'm ecstatic right now. Adjust T8 until the station is at its loudest and reduce the volume if necessary. Ah! 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 It shouldn't say loudest, it should say crispest. Crispiest! Retune the radio for another weak station and repeat this procedure until no more improvement noticed on the weakest possible station. Process peaks the IF amplifiers to their maximum gain. The rest of AM radio is just fucking silent. Unless... No. I'm not getting any other stations. Ow. Antenna alignment. Tune the radio for a station around 600 Hz. With the magic wand, place the brass end near the antenna coil as shown in figure 32. If the signal heard at the output increases, it means that the antenna coil needs less inductance. Why doesn't it just say it? Okay. Place the brass end near the antenna coil as shown in this here. Magic wand, brass end. If the signal heard at the output increases, it means that the antenna coil needs less inductance. To remove inductance, carefully slide the antenna coil along its ferrite core to the left. Place the iron end I'm getting nothing, by the way. Nothing. I've only got one station, but I haven't got anything. Repeat these steps until the signal heard decreases for both ends of the magic wand. Place the iron end. If the signal heard at the output increases, it means the antenna coil needs more inductance. To add more inductance, carefully slide the antenna coil along its ferrite core in the direction shown in figure 32. I'm gonna remove this. We are getting it through the speaker. Barely. It's a shitty speaker. There's a baffle in here, but that's for later. That is for later. I'm surprised this thing works. I'm gonna shut this off for the moment because I read something earlier in here that made me believe that I wouldn't have to adjust volume across stations. And clearly that is not the case. I'm having huge, like massive, I have to make a massive amount of change to the volume as I change frequency and stuff. Yeah, here we go. Okay. Without AGC, so I wonder if I fucked up something having that fucking shorted out still. The purpose of the automatic gain control AGC circuit is to maintain a constant level at the detector regardless of the strength of the incoming signal. Without AGC, the volume control would have to be adjusted for each station, and even moderately strong stations would clip in the final IF amplifier, causing audio distortion. AGC is accomplished by adjusting the DC bias of the first IF amplifier to lower its gain as the signal strength increases. Figure 22 shows the audio at the top of the volume control is actually riding on the negative DC voltage when strong signals are encountered. This negative DC component corresponds to the strength of the incoming signal. The larger the signal, the more negative the component. At test point 5, the audio is removed by a low-pass filter, R36 and C32, leaving only the DC component. Resistor 35 is used to shift the voltage at test point 5 high enough to bias the base of transistor Q8 to the full gain position when no signal is present. Resistors R35 and R36. Also, forward bias diode D4, just enough to minimize on-condition threshold voltage. Is it raining? Oh yeah. And it's getting light out. Weird. I'm gonna pop open this window because I didn't know it's getting light out. And raining. It's not particularly raining anymore, but it did rain. Alright, so I have reason to believe that something is messed up with the AGC. The AGC Section 2. One B. This is Section 2. Section 2 is in here. There is a thing in here that says AGC. Where is it? Here, right in the middle there. It says AGC. I'm gonna take a look here. At all the stuff that's going on. Those two are supposed to be connected. I've got this. Where is this? There it is. I've got this. Okay. I mean, the only thing I can think of is these two here that, like, they don't have a connector. They don't connect to anything. I don't know. I tried doing something to one of them, but nothing happened. So I was like, yeah, just fuck it. But everything back here actually looks really decent compared to this section over here. Yeah, the lead solder is nice and shiny. I mean, it could just be that, you know, it's because of the size, the width of the stuff that I was using, but everything looks alright. That one looks a little funky, but I mean, don't know. It looks fine to me, I guess. These are all facing in the correct direction. They've all got the basses out in the basses. I don't know. I don't know. Good thing. Good thing. I don't listen to AM radio a whole lot. We're gonna plug this back in. Turn it back on. Loud. Do, do, do. What station? This one is like around 700. It's probably 680. Yeah, it's pretty close to 680. 680. It says full service, so that must mean music and everything else. WDBC Escanaba. AM 680, the Information Authority, America's best music. Alright, well. This thing is not doing anything. AM 680. WDBC Escanaba. Hell yeah, man. This is gonna be my favorite radio station now. Favorite. I'm not getting shit. Oh, jeez. Tune the radio for a station around 600. No, I heard something. An awful noise is what I heard. Turning it very slowly. No, I'm coming back to 680. Oh, I reach capacity. Oh, I mean, now's a good time to stop for the moment. I think it's raining again. Yeah, it's raining again. I love when it rains. Alright. So, I think concludes the live broadcast.